Here's a table that shows some input and output values of an exponential function g. The equation g of x equals 3 to the x power defines the function. How does g of x change every time x increases by 1? Each row of the table represents a point. When you examine consecutive rows, or points where the x values increase by 1, the pattern in the g of x values is a constant ratio. It doesn't matter which pair of consecutive values you choose, the ratio is 3 every time. For an exponential function, the constant ratio can be found by dividing consecutive g of x values. Now, let's look at points that have a change in x that isn't 1. From x equals 3 to x equals 6 is a change of 3. How does g's output value change as x increases by 3? If we use the points from the example, we would be comparing the point 3, 27, and the point 6, 729. Dividing the y values results in a ratio of 27, which is equivalent to 3 to the third power. The base 3 represents the constant ratio. The 3 as an exponent represents the fact that the points are 3 units apart on the x-axis. Complete the table with the output when the input is x and when the input is x plus 1. Each g of x value can be rewritten with base 3. 27 is the same as 3 to the third power. 81 is the same as 3 to the fourth power, and so on. Basically, each g of x value can be rewritten as 3, which is the constant ratio, raised to the x power. That means when the input value is x, g of x is 3 to the x, and when the input is x plus 1, the output is 3 to the x plus 1.